A bank agrees to lend 10,000 now and X 3 years from now in exchange for a single repayment of 75,000 at the end of 10 years. The bank charges interest at an annual effective rate of 6% for the first 5 years and a force of interest delta t equals 1 over t plus 1 for the next 5 years. Calculate x. So x is the additional amount that was deposited at time 3. So okay, the additional amount that was lent at time 3, because 10,000 first 10,000 was lent, and then another X was lent 3 years later, and the final exchange that the bank wants is 75,000 at the end of 10 years. So we basically have to see how much this 10,000 and this X will grow, and the sum of the growth of the two should equal 75,000 in 10 years. So then let's first focus on the 10,000. So 10,000 was deposited at time 0. So for the first 5 years, it gets annual effective rate of 6%, which means compound interest of 6%. So it grows into 10,000 times 1.06 power 5 into 13,382. And during years 5 to 10, the growth is under force of interest. So this is kind of the principle starting at time 5 now. And so we have this one. And the force of interest, we want to see what happens between times 5 and 10, because that's when the force of interest kicks in. So the principle times e power 5 to 10, in this case, times delta t dt. Remember, force of interest, the generic formula. Okay, so maybe we can write it down, the generic formula once again. Let me get it from the previous one. Okay. Copy. Okay, so let's put it over here. The amount formula for force of interest we know is this one, but remember that 0 is the starting time in the above equation. So in this case, if the starting time is 5, because that's when the formula kicks in, then 5 takes the place of the 0 in this main formula. So it's the 0 to t will actually be 5 to 10. So the 0 to t should be read as a time duration from the beginning to the end. So in this case, the beginning is time 5, because that's when the force of interest starts. And so we go from 5 to 10. And this P should also be read as the amount when the force of interest starts kicking in. So usually it's the principal at time 0, but in this case, it's the amount at time 5, because that's when the force of interest starts kicking in. So the force of interest is 1 over t plus 1, and this integrates to ln t plus 1 from 5 to 10. So when you substitute 10 plus 1 is 11, so ln 11 minus ln 6. Which by log property, ln A minus ln B would be ln 11 by 6, and now the E and the ln cancels out. And so you have 13,382 times 11 by 6, which is 24,534. So this is what the 10,000 that was lent at time 0, that's its value at the end of 10 years is 24,534. So now let's see what happens to the other lending, which was X, and that's happening at 3 years. So from time 3 to 5, there are 2 years, and in those 2 years, it will grow under the compound interest of 6%. Remember, for the first 5 years, we have the compound interest of 6%. So the X in 2 years, because there are 2 years between time 3 and 5, will grow to 1.06 square. And then there are another 5 years from 5 to 10 when the force of interest kicks in. So this is a starting sum at the start of the 5 years, x times 1.06 square. And again, e power 5 to 10 delta t dt, which we found above is 11/6. So this is the expression we have. To which this second lending of X that happened at 3 years will grow at the end of 10 years. So some of these two growths should equal 75,000 because that's what the bank demands at the end of 10 years. So the first one was 24,534. That's what the initial 10,000 grew into at the end of 10 years. And then the second X that happened at 3 years grew into this one. And the sum of these two should equal 75,000. So when you subtract the 24,534 from 75,000, you get 50,466, and then you multiply this by 6, divide by 11, divide by 1.06 square. So you get 24,499. That rounds to choice C because choice C was 24,500, and they're all rounding to the nearest 500.